Good morning, ladies and gentlemen. Welcome back. Today is Wednesday, October the 7th, and we're looking at the new unit on transformations of functions. And the first part we're going to look at what's called base and parent functions. So that's what we call them. And again, people in the classroom, feel free to write notes in your notebook or on the back of that handout, right? Because that's what I gave to you. The reason why we call them base or parent functions, it's something to refer to eventually what we're going to manipulate. For example, in, let's say, hockey, especially the NHL, right? There is a standard of equipment. What is it? What does that mean? In hockey, you usually have to have skates, you have to have, shin pads, guards, hockey stick, helmet, pads, jersey, and of course know how to skate, right? That's the uniform or parent or standard. You don't see people in hockey going out with football gear, right? And like guns or anything, or that's not the standard uniform, right? The standard uniform is with skates, and the skaters aren't having skates on their hands, right? That's silly, right? That's just silly. So we're talking about base and parent functions. In fact, the first equation you already know is y equals x squared. A lot of you already know this is y equals x squared. So I'm going to be referring to an equation, a table of values, and what it looks like. And this one is so obvious, just like one of your classmates noticed. We've already kind of talked about this. This one, and I apologize if you have to pinch the screen, you can do a table of values, right? So a lot of you understand, these are going to give us 5 critical points. And technically, a lot of you realize there's actually an infinite number of what's called critical points. 4, 1, 0, 1, 4. A lot of you have done this in grade 10, but just to refer, this is the first one. And if we were to plot these 5 critical points, hopefully you're doing it with me right now, it's going to look something like this. I'll get out of the way. And that's my sketch. So there's 3 things we're kind of teaching you at this point for learning all of these. And again, eventually, sorry to say, you have to know what these look like almost innately. Here's the equation. This is the table of values. This is what it looks like graphically. Can I get a volunteer from the class? Really, really easy. What is the domain? What is the range? No pressure. Notice, we no longer look at the critical points. These are called critical points. We look at the graph. Any volunteer? Maria?
X, any real number, and then y greater than 0.
Close, so close. Want to clean that up?
Greater or equal to 0.
Nice. Because it actually is touching at 0, right? Because it is 0, 0, right? So a lot of you understand that. Everyone okay? Pretty easy. So we have to first establish the parent functions. I should follow along the same thing. So this, I think, was the one on the left. And again, notice I didn't go all the way to negative 4 before. It's a little silly. Okay. The second one, and I might have you, I'll have to read it. A lot of you know what this is. We've already talked about square roots. Square roots. So the way that I like teaching this is the table of values. I tend to do it like that. The handout actually starts at -1, but I like going at -2. And the reason why I try to mirror what you're doing, just in case you forget. It's okay at this stage if you don't know what this is. But if we take the square root of -2, notice a lot of you say, well, that's a complex number. And again, the graph for this has to be only plotting real points. So the answer for -2 in this case, there is no answer, right? There's no real answer. The square root of -1, there is no real answer. The square root of 0, I think a lot of you understand, square root of 0, it actually is 0. So unlike the parabola, the table of values, which a lot of you realize is just like how Maria gave us the answer, the domain was x belongs to our brother. Any x values we could theoretically output. But when we talk about critical points, I think a lot of you agree, and I'll highlight this hopefully in orange. 0, 0 is a good critical point. How about the square root of 1? Any volunteer? No pressure from the class here. Anyone know what the square root of 1 is? No pressure.
1.
It is 1. Nice. And look, that's a nice critical point. The square root of 2. If you don't know what that is, Can someone help me out with the calculator? Square root of 2? 1.414. Yeah, it keeps on going like this. And notice, it's irrational. This is clearly not a nice point to plot, but you could, in theory, if you were a robotic automaton, you could say 1.41. You would know how to read that. Square root of 3, also, it's like 1 point something. Thanks, guys. You guys are the greatest. See how core B? You gotta be the core A. Anyway. Fight for Mr. Chen's love. No, not me. Anyway, so these are the values. Let's square root of 4.
2.
Nice. Look at you guys go. So these are 3 critical points. Before you continue, the check marks represent key points. I call them critical points. I think other schools might call them key points. K-E-Y, but then people say, where's the lock? No. Critical tends to be easier. And so when we want to graph this, and I will, nope, I am still in my zone. Hopefully you're gonna draw those 3 critical points. I'll use orange, hopefully to show you. That's the 0, 0. That's the 1, 1. And this is probably the 4, 2. And as you slowly kind of graph them together, that is the root function. Close that door. Is that your? Does anyone know? Huh? Any question about the root function? Really easy. Can I get a volunteer? Tell us the domain and range. Notice now you can see it. Any volunteer? Saba.
X is greater than or equal to 0.
Nice. Such an excellent real numbers. And range.
And Y is greater than or equal to 0.
Nice. Notice we're going back. We're going to revisit domain and range. Let's just make sure we make it clear. Some students would argue, but Mr. Chan, this kind of looks like, and it is related, to the parabola. And some students would even say, Mr. Chan, is this root function, is it a sideways parabola? And I say, please don't ever say that to me. Do not ever argue with that. Why? Because you've learned that parabolas either open up or open down. Right? So this is not a sideways parabola, this is the root function. Before we continue, everyone okay? Any questions right now? Grace!
So the base parent function refers to just that first quadratic one, right?
That is correct. You'll see in a while. So I'm trying to get through the 5 parents. This is the first one, that's the second one. And we'll go through it. Yeah. And that's why, unfortunately, this is why a lot of students find this difficult, because in grade 9, you want to learn the straight line, and then grade 10, you want to learn the quadratic, and then grade 11, damn! So many functions! Saba!
What do you use all the functions for?
What's that?
What do you use all the functions for?
Good question. What do you use these functions for? Well, I'll give you 3 specific references. 1, video games. 2, art. 3, music.
No, music.
Absolutely. Here we're going off on a tangent, ladies and gentlemen. Yeah, that's pretty good, right? So, in music and stuff like that, whatever, I can't draw my stuff. Let's just call it chord stuff. So, when you have a note like that, and then you change the key and transform it to major to minor, hey! Functions. So that's what we're talking about. You'll see it when we do it. But right now, we're making it easy. The music's hard. Music's hard. So you'll eventually learn it.
Music theory is like also really.
It is math. It's math. You guys just don't believe me, but you know, whatever. Let's keep on going. Number 3. We're going with the columns. Is that okay? We're going to do the third one. So the third one is y equals x cubed. So let's do a table of division for this. And this time, ladies and gentlemen, I'm only going to do those 3 of those 5 critical points. Take your time, go slow. Any volunteer want to output the y values? If you have to use the calculus, fine, but a lot of you can do the mental math. Any volunteer? Flora?
-8.
-8 is correct.
-1.
That is correct.
0.
Nice.
1.
Yeah! Yeah! So again, don't feel bad. You're not meant to memorize these, but eventually some of you will. The cubic function, it's interesting. It's actually harder than you realize it. You just introduce it now, and you'll look at these higher order polynomials in grade 12. So at least that's what we're trying to do, plant that seed in your brains. And if we have more time in enriched math, we'll do it. But all you have to do from this, and again, hopefully a lot of you realize, these are again 5 nice critical points. Bless you. And I'm going to just exaggerate it. So that's line 0, 0. That's 1 and 1. That's -1 and -1. That's 2 and 8 way up here. And I apologize. I didn't get that. So what is this going to look like? So I'll use colored chalk, so it looks a little interesting. And the people at home, hopefully, if you're really, really lazy and you don't do this by hand, I think this is always perfect. But you could definitely use technology to reinforce it. You could definitely grab your cell phones and check using some graphic programs, which I'll mention later at the end of this video. It looks something like that. Right? And I hate this. So I'll hold you up there. Just like that. What does this look like to you? Let's get some people from the class. Any volunteer have a good word?
A squiggle.
Nice! I actually like how you said that. It is the squiggle. But unfortunately, some people say, Mr. Chad, let's have like a sideways S or reverse bizarro thing, whatever.
No.
But
It's a squiggle.
But squiggle is good, but it's not official, right? And we just call it what it is. This is the cubic. Right? Because it's the cube. That's what this looks like. Notice again, just to talk about it, although in grade 11, and honestly what we're interested about, a lot of you are looking at the 0, 0. Right? In grade 12, we actually are interested specifically about end behaviors. And so this graph, this cubic looks like this. Right? It goes like this. And I'm doing it towards your reference, right? It looks like this. Not like this. This one. Right? So it looks like that. So the end behavior here. Any volunteer want to give us the domain and range now that you can see it in the graph? Only 7 I are playing. Flora?
Both are real numbers.
Yeah, so I don't like that answer.
So the
Domain is x belongs to real numbers, range is y belongs to. I don't like hearing like it's the same thing for both answers. Like, I don't like that. Like honestly, ladies and gentlemen, if we came to class and I said, today's lesson, ladies and gentlemen, here are the answers. Good night, everybody. Like I just gave these answers out. Like here, today's lesson. Here are the answers. 7, red, yes, true. I'm done for the day, right? That you like hate me, right? That's not how math is. It's supposed to be procedural. So you try to. This video is going longer than that. That's okay. Any questions about the cubic? Question on the cubic? Questions? And we'll talk more about cubics. I think. Well, if we had more time, we would talk about other cubics, but this one's kind of neat. It is a squiggle. We're going to skip the exponential function if that's okay. You can try it yourself if you really, really want to. But we're actually going to look at that in the future on your exponential course. Absolute value, here it is. This is hopefully new to some of you. And Mr. O actually has a good worksheet. And I'll write this one. Absolute function. We're not talking about the alcohol, so you might know that. These lines don't mean parallel. It just basically defines the magnitude from the origin. So notice, that's why I tried to show this to you. This y equals with these lines. It looks like this equation. Everyone agree? This is why I have to show you this one, even though it's not on your sheet. So what does this really mean in definition? It basically means whatever you evaluate in these absolute signs, it yields a positive answer. That's all it is. So inside here, it yields a positive answer. Unfortunately, no offense, in grade 12, this is kind of a hard concept, so that's why we just want you to get familiar with it. And this is the idea of what's called cases. The analogy also is like when we did quadratics, we have two roots. So there can be scenarios where things might be true. So let's do a table of values for this. I know this is going to seem weird. So when we plug in -3 into this, it becomes positive. So that's the answer is 3. We plug in -2 into this, it becomes 2. So a lot of you understand that. -1 becomes 1. 0, notice 0 is neither positive nor negative. When you plug in 1, it yields a positive answer. So 1, 2, 3. Don't get so caught up, ladies and gentlemen, on the absolute value. These are actually, these questions, like I'm not going to give you an equation where you have to evaluate. I would rather you kind of just grasp it from what you're seeing, like from the ground. So, hopefully someone will beat me to this. Any volunteer want to describe what they're going to see? I'm not going to do it until someone tells me. Hopefully, we'll get someone else. Audrey, what do you think you're going to see? It's like a V is correct. V for victory. It is the V, right? Because again, the critical point is 0, 0, 1, -1, 1, 1, 2. Okay, I think you know what I'm doing. And that's why I'm just sketching. Hopefully you'll eventually graph. And that's what I'm asking in practice, but the sketches just help me speed it up. So again, we'll do a quick, summary after I record through this. Flora, really quickly.
Just a question. What if we put like imaginary number into?
Good, I'm not gonna talk about that. We're not gonna talk about that. It's something to think about though, and I'll be honest, I actually don't know the answer. We could check it out later too for enrichment when I show you Desmos, but I don't know. There's only so much I know right now. Anyone else so far before we get to the hardest function? The last one is called actually the reciprocal function or reciprocal linear function. And I need to use all the room here. And that's why technically I gave you the graph piece of paper. Can I erase this? Okay. So hope you're, just like Grace is reinforcing, we're looking at the equations, we're doing a table of values, and we're looking at the graphs. And really what I'm trying to get you to do eventually is innately know what the parent functions are. But our last graph is y equals 1 over x, and it looks like y equals x, but it's 1 over x. That's why it's the reciprocal linear function. Now, honestly, no one actually ever calls it this, but you'll see in a moment. And I think we'll actually do exactly what this handout says. So this time, I'm actually going to follow the instructions here specifically. And this one I do encourage you, please, please, please ask me anything you want. And I don't know why they did it like this. Oh, because of the room. So I'm gonna do it like this, is that okay? So -10, -6, -4, -2, -1, -1/2, and -1/4. I'm gonna skip the 1/6 and the -1/10. Is that okay? Even though you could go further, and I should have more room, right? That's why this hand is not the best. So over here, it's in continuation with 0, and 1/4, and 1/2, and 1, and 2, and 4, and 6, and 10. That's why they did plus or minus. Technically, a lot of you are going to see a pattern eventually, but let's pretend you don't know the pattern. When you plug in -10 into this, I think everyone agrees we can get a decimal or a fractional answer, right? And that's what you're supposed to be doing in 2 columns. So it doesn't matter to me. Let's just stick with 1 form. Is that okay? We'll stick with decimal. Is that okay? Or unless, do you like fractals? You guys like fractions? Okay, no, one person. Most people not. Sorry, Eric. We're gonna stick with fractions. So negative 10 in this is negative 1/10. But I will put this out as negative 0. Right, everyone agree? So if you want to do that yourself, you can. Negative 1/6. This one's actually hard. Anyone actually know what that is? Nice. Keeps on going, right? Repeating decimal. Nice. Look at you. Look at that. Mr. O must have done something good. Negative a quarter. This is easy. Negative a quarter. Some are realizing it's becoming more and more negative, right? But let's do this one. Negative 2. Anyone else? Thanks, Danielle. Negative 1/2. Or negative 0.5. Notice what I'm doing, ladies and gentlemen? I'm trying to illustrate some of the critical points. Those blue ones are good, but this one's clearly a nice point. I know it's still fractional, right? At least this one is obvious. When you plug in negative 2 into this, that's a negative half or negative 0.5. Everyone see that? How about negative 1? Well, negative 1, when you plug this in, anybody? It is negative 1. Hey, this is amazing. This is amazing. Critical point. Okay. How about negative a half? It's negative 2. It is an amazing critical point. And then negative a quarter? Negative. It is. This is kind of hard. The y coordinate is fine. Oops, actually. But it's not because this negative coordinate is hard to plot. Everyone agree? The y coordinate is fine, but the x coordinate, this is suspicious. But we at least get 3 nice critical points. Everyone see that? So we're just going by pattern here. How about when we divide by 0? Hey, look at that, ladies and gentlemen. Related to our test that you just wrote. No pressure. 1/0. What do you think the answer is? If you give me a bad answer, I'll throw Grace at you. She's so small.
Undefined.
It's undefined, so there's not a. What the hell, Chad? That's not nice. How about a quarter? Can someone actually finish these off? And again, I like doing it this way. Don't get me wrong, this table is also good. It's just that I think some of you might be getting tricked with the plus or minus. That's why I decided to do it this way. Can you actually give me all the answers here? Just like that. Yeah?
4.
Yep.
2.
Yep.
1.
Yep.
1/2.
Yep.
1/4.
Yep.
1/6.
Yep.
1/10.
Yeah. Oops, I didn't do it. 1/4, 1/6, 1/10. And again, some of you are looking at this. What are the critical points? These 3. Before we continue. If you forget this, don't worry, you can always generate it. Does that make sense, ladies and gentlemen? The reciprocal or linear function, the reciprocal linear function, it is the hardest function to teach. Why? Because it looks weird. It looks weird. To illustrate the sketch, and if you want to wait, that's also okay. Watch what I'm going to do. I'm actually going to focus on the first 3, the negative region. That's my negative 2, that's my negative 1, that's my negative half. That's my negative 1, that's my negative 2, that's my 1, 2. I'm just focusing on this part. Don't get me wrong, end behaviors are really, really important, but for us in grade 11, we are interested in plotting these critical points. So I'll use orange chalk to plot it. The negative 2 and the negative half, negative 2 and negative half, right about there. And the negative 1 is right about there. And the negative half and negative 2 is right about here. This is going to look something like this. How about the other 3 critical points? On the right hand side, we'll use yellow chalk. Because it looks like I'm using 2 different lines. But a lot of you realize this was one equation, y equals 1/x. So at positive a half, it was 2. At 1 and 1, and then 2 and a half. And And notice what I had to do, ladies and gentlemen. If I were to go from left to right, or bottom to top, I had to lift my chalk. Right? If I could trace this out, lift up my hand, and that is the function. This is the reciprocal function, and it's the weird one. Let's pause here for a second. Any questions? There's a new concept we have to reinforce for this, and I'm trying to go as slow as possible. Hopefully at home you can hear me. In blue chalk, there's not one, but two straight lines that you can't really see. The analogy is, maybe some of you might have learned in chemistry class, grade 10, science, called lone pair electrons. The electrons are there, but they cause a shape that affects the molecule. That's kind of what we're talking about. The two lines I'm talking about, the first blue one is here, and this other one is this one. And these blue lines that I've drawn are called asymptotes. Asymptotes, that's the new word for today. Just to quickly get through it, don't worry, we'll talk more about this in detail, probably online. I just want you to know what this is, but although the other functions, domain and range, is pretty easy, I'm just going to do the domain and range for this one first of all before I talk about the asymptotes. The domain for this is x belongs to real numbers, except x cannot equal 0. And the range, y belongs to real numbers, except y can't equal 0. And notice what this is. X cannot equal 0, y cannot equal 0.
No restriction.
It's the restrictions. Yeah, it's the restriction for this. But anyone see anything interesting about 0 and 0? And the blue line? No pressure. Alan.
They never touch, like the other one.
Yeah, good. The yellow and orange line never touch it. That's good. But I'm focusing about this restrictions of 0, x, 0, and y. No pressure. I'm trying to do something visual. It'll help. Flora.
Those two are the x and y axes that you should never touch them.
Again, that's good. You're saying good stuff. This is all true. You're good. That's not what I'm thinking of. I'm actually looking at this diagram. Let's zoom in so people can see it. I'm looking at this. Audrey?
Do you mean like the blank dot thingy? Like the dot that isn't colored in? The circle
Yeah.
that isn't colored in? I don't know what it's called.
Circle that.
Okay, I'll take that as a no.
Yeah, like it's never gonna meet there.
Yeah, they're never going to meet there. That's good. All three of you are amazing. That's not usually what kids say to me. But when they see the blue lines that I've drawn and influencing this, and I'll say it again, this is 0 for x, not equal to 0, and y not equal to 0. Maria, do you know what I'm talking about?
The asymptotes touch those 2 points?
It doesn't touch 2 points.
Like
it
it
touches
0?
Sorry?
0?
Do you know what this point is called?
Origin.
It's the origin. Oh. And it is the intersection of these asymptotes.
What's the asymptote again?
So these asymptotes, just like your classmates have said, these asymptotes cause the function to get closer to it, meaning this side gets closer and closer and closer to the y-axis, but never touches it. Similarly, on the x-axis, this part, or even this part, these end parts, they get closer and closer to the x-axis, but never touch it. Okay? So asymptotes are regions that actually draw the function closer and closer to, but never touch. And there's an internet meme. There's a picture of Gandalf that some kid has drawn on their thing. It says, "You shall not pass." There's a picture of Gandalf, and I don't know if you know who I'm talking about because it's an old movie, Lord of the Rings, one of the greatest movies ever. When he fights the Balrog, no, none of you. The asymptotes are like regions of space which draws it. And again, there are two of them. One's called the vertical asymptote, VA for short, and one's called the horizontal asymptote, also HA for short. And the vertical asymptote is the equation x equals 0 and y equals 0. Notice these lines are not part of the function, but they're a property of what you can infer from the reciprocal function. I'll say that again slower. 0, 0 is clearly not a point that graphs on this line. but nonetheless, it helps us determine a seventh critical point. 0, 0, although it's not part of the function, it is the intersection of a vertical and horizontal asymptote for this function. To illustrate this further, no pressure. If x was equal to negative 1,000, where's negative 1,000? Negative 1,000 is way, and I'm sorry I'm off the screen, it's way over here, right? Negative 1,000. But what would that y value be? 1 over negative 1,000, right? Everyone agree? It's not 0, it's never gonna, it's getting really, really smaller. It's gonna get closer. How about a million? Negative a million. Well, then it's 1 over negative. I think a lot of you understand what I'm doing. It's never going to be equal to 0 because you can't divide by 0. Before we continue, everyone okay? So those are the 5 parent functions that you need to know. Okay? And we'll talk about that in a moment.